How to train the terrestrial linear neuron. This one comes from the textbook of Satish Kumar, the neural networks, the classroom approach. So if you want to study or if you want to read more, you can visit some Google books and you can see some part of that books. I think it's quite a good book. So there are a lot of equations, a lot of proofs, so you can understand the ideas behind each kind of perceptron. So guys, in this video, I'll show you, and we follow this. Sorry, I follow this equation and try to make you understand everything about how can we train and why we use that equation. Can you remember the equation? The equation is like a very simple w dot x if if w dot x is greater than 0, but, or you can think that, and this one will be the positive class, right? The positive one, the one that will fire the output signal to other neurons. So this one is if the summation is greater than 0, and this is not the positive one, and it is a negative class. So what should we do? Can you remember? Can you remember? We'll use the blue, because this one is like greater than 0 is too much, because it's greater than 0, but we need something like it is negative 1. So we have to decrease it. So the blue will be the blue minus eta x. This one is from the previous videos, right? Else if use Python style, else if w dot x is less than 0 and it is a positive one. This is positive one. So it means that it is like less than 0. So we would like to make it the summation a little bit higher to make it greater than 0, right? Because it's positive. We expect something that is greater than 0. We expect the summation to be greater than 0. So we'll use the blue to be the blue plus eta x. The reason behind this is, like, you can think that this video is an option that if you know how can we adjust, and how can we learn the way. Maybe you don't want to understand the reason behind this, but if you want to understand, I'll tell you here. Okay guys, now we have the equation. For example, you can imagine that we will have the only the and or operation. Please take a look at this. If we have and or operation in like only two inputs, so we need x1 and x2, right? And we have w1 and w2, and of course we must have w0 and x0 to be 1. This one is the basic structure of the perceptron that gets two inputs, that is x1 and x2, and we have the part that would be the output. So look at this. Our equation is w0 plus w1x1 plus w2x2, that must be greater than 0. Look at this. Now we are in the space of input, right? If we are in the space of input, the one that you can see is we will have x1 and x2. And if we talk about the OR operation, the OR operation is like this is 1, this is 1, so this is positive, 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 and this one is the negative one. This is the OR operation. This is OR. You can think that this one is the OR table. And once we have a line here, or for example, I'll make it like closer to the line that we have. We had in the previous example that the line that pass 0, 0.5 and pass this 0.5 and 0. Okay, so I hope that you can still remember. This one is the data from OR table. This is the space, 2D space of X. But guys, if we would like to find W0, W1, and W2 that can classify this example, we have 4 examples, right? So look at this. We have a lot of lines that can classify this, right? We have infinite number of lines that can classify these examples. So, and where are they? Where are they? So you need 3 parameters, right? In this case, you need 3 parameters to be trained. 3 parameters are W0, W1, and W2. So guys, if we change this into the space of W0, W1, and W2, like this, look at this. If we have the V1, the V axis to be W0, and we have this part to be, this one is for W2, and this one is for W1. So we have the space that can be used to classify. So we need some part in this space, like for example, the one that we had here is how do you remember? We have the weight like minus 0.5 plus W1 plus W2, oh sorry, plus x1 and plus x2 must be greater than 0. So the weight is 0.5, and 1 and 1. The idea now is like we will use this part W0 to be minus 0.5, and W1 will be 1, and W2 will be 1 also. This one will be 1, and this is 0.5. So guys, if we would like to make it like this is the space, so this point is one of the solution. Oh sorry, we must drop it down by 0.5. Okay, so sorry, so this one is one of our answer. But how many of them? So I think you know that is infinite, right? So how can we find it? How can we find it? To make you be able to understand it clearly, and I think it is easier for us to understand this in 2D dimension. So guys, I will show you the plane of W0 to be 0 first. In the case that W0 to be is indicates that W0 is 0, and we project this view from the top view. So you have two lines, two axes. This one is W2 and the other one is W1. Okay, now it's time for us to completely change it into the space of X into the space of W. So at first, look at the first example. I'd like to use the fourth one first. We have x1, we have x2, and we need the output like this. We have to be like 0, 0, 0, 1, 1, 0, and 1, 1. Guys, look at this. The output is, of course, is false, true, 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 right? So I'd like to demonstrate the last one first, because it is like it is the most like the most the example is like very the easiest one to demonstrate in this space. So guys, if you have x to be 1 and 1, now we force it. Our equation is like our equation is W0 plus W1 x1 plus W2 x2 is 0, right? This is our line or our hyperplane, or you can think that this one is the decision surface that you can use it to classify the example. So this one many people call the decision surface. So you have a lot of decision surfaces, or you can think that this one is a hyperplane. Okay, now we come back here and we have x1 and x2 to be 1 and 1. So please look at this. If we convert this part into the space of W1, W0, 1, and 2, so x1 is 1, and of course x2 is 1 also. So what we have is we have W0 plus W1 plus W2 to be 0, and we force it to be the plane that W0 to be 0. So this one is also 0. So what we have here is W1 plus W2 is 0. So guys, please look at this. I will move it a little bit higher here. So what we have here is, what we have here is this one, this part. So guys, W1 plus W2 is 0. What is it? What is this line? What is this line? You can imagine that this one will be W1 is minus W2. So now what we have will be changed like this. This line is here, right? Oh, sorry, it's not. Okay. Okay. This line is, for this example, the last one, E4. If we define it to be E1, E2, E3, and E4, this one is E4. The line is W1 equal minus W2, right? Right. So and guys, if I use some point here and some point here on the other side of the lines, guys, look at this. If W1 is 1, W2 is 1. If we have a point here, that is W1 is 1, W2 is 1. Is it this 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 weight can be used to classify the E4 one? You have to take a look at this, because our equation is for W4, this one, right? Our equation is W0 plus W1 plus W2. It must be greater than 0, right? Right? So W0 is 0 plus 1 and plus 1 greater than 0, right? So 2 greater than 0. So you can imagine that this one is the representative of all 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 weights on this side. And how about this one? If I select -1, some part here, -1, so you can imagine that this one is 0, -1. Is it true? No, right? No, it's not true. So it's false. So you can imagine that for all parts that is on this side, can be used to classify E4. All data, all weights here can be used to classify E4. This part. Okay. And now guys, look at this. How about E2 and E3? The first line is E4, right? How about E2 and E3? Take a look at this. We will focus on E2. What is E2? E2 is x1 and x2 will be E2 is 0 and 1, right? So our equation is, I'll use W0 plus W1 x1 is 0 plus W2 x2, that is 1. This one must be greater than 0. If you want to find the line, you have to check that. Okay, which line? It must be equal to 0. And our W0 is 0. This term will be 0. So our W2 is 0. Where is our W2 is 0? W2 is 0 is here. So I'd like to make the line a little bit thicker. So this one is for E2, right? E2. And which part of E2? Up or down? Over or under this line? You need something that is W2 must be greater than 0, right? Right, because this part is the summation. So W2 must be greater than 0. So this is W2. W2 must be greater than 0. So all points above the line, can be used to classify E2, right? For example, if you choose some point here that is like 1 or 1.5 minus 1 and 1.5, for example, this is 1, this is 1, so this is like approximately minus 1.5. So guys, W2 greater than 0, right? And W1 is, of course, W1 times by x1. So this one is 0. Okay, so this part is, of course, another one that is like, so you can use this area to classify x2, E2. Okay, and next. So guys, can you see the overlap area? Of course, in this area, right? This area, this is the overlap area. So all points in this area can be used to classify E2 and E4, right? Okay. So next you have to check with E3. So what is E3? E3 is x1 is x x1 and x2, they are 1 and 0. So our equation is W0 plus W1 x1, that is 1, plus W2 x2, that is 0. So it must be greater than 0. But if you need to find the line, you have to use equal. So this one is 0, of course, and this one is 0. So you have W1 is equal to 0. So your line will be W1 is 0. So the line W1 is 0. I'm going to make it thicker here. So this one is E3. But you need that to make it like W1 that must be greater than 0 to make E3 to be positive. So the last one is this part. Okay, so guys, every point, everything in this overlapped area can be used to classify E2, 3, and 4. Okay, so you can use every point here in this part to classify all of them, E2, 3, and 4. So I will rewrite it again. So every point here of the space W1 and W2 can be used to classify E2, E3, and E4, right? Right. You can pick up just only one point, any point here, like this one maybe like 10, 1. Yes, it can be used to classify W0 plus W1 plus W2 must be greater than 0. This one is 0. So W1, sorry, W1 x1, W2 x2. So in the case that we have E2, 3, and 4, right? That is x1 and x2 will be 0, 1, 1, 0, and 1, 1. So all of them can use the weight in this part, and everything must be greater than 0. So you can imagine that you can pick up just only one, pick up the first one. So x1 is 0 and 1, and you pick up W1 to be 10, right? And W2 is 1, right? So the summation is 11. That is greater than 0. So you can pick up any point here, and the result will be true for all of them. So you can check for the second one that x1 is, this is the second one, x1 is 1 and x2 is 0. So it will be 10, right? It will be 10. Oh, hey, sorry guys. For the first one, maybe it's incorrect. For the first one, x1 is 0, x2 is 1, right? So this time, this will be 1. 1 greater than 0, that is true. I'll go to the next one, this one. So guys, in the second example, x1 is 1 and x2 is 0. So this one, x1 is 1 and x2 is 0. So 10 times 1 and 1 times 0. So it will be 10 greater than 0. 10 is greater than 0, so it will be like positive again. And for the last one, x2 is 1 also. So the summation is 11. 11 is greater than 0. So you can see that now we can use 3 of them to classify all example here. So if you can pick up any point in this area. Okay. So guys, how about the last one? The E1. E1. X1 is 0 and X2 is 0. W0 is 0. So guys, I'd like to use this area. So in this case, W0 plus WI XI, that is 0, plus W2 X2, that is 0, must be greater than 0. But W2 is 0, this term is 0, this term is 0, must be greater than 0. So guys, we have no points that can be used to classify E1. It is 0. It is 0. So in this part, the area in here, it can be used to classify E2, 3, and 4, but cannot be used to classify E1. Okay, so you have to move. You have to, if you want to make it to make E1 to be lower, you have to move W0 to a little bit lower than this point. You can move it, like, for example, if in our example we move it to be minus 0.5. So you can make it, you can find some area there. Let's see in the next video clip, because this clip is quite long. So I would like to divide it into 2 parts. Okay guys, see you in the next part.